Hey everyone, welcome back to our SwiftUI Develop in Swift tutorial series. I believe this is video number 10, and today we're scrolling down pretty far back into data modeling. We're going to be taking a look at Chapter 4, Observation and Shareable Data Models, and we're going to be building an iPad match/ordering game in order to learn how we can share data between views and also, kind of create a little bit of a game with some logic. So I'm going to go ahead and click on the Complete a Game with Logic. Link is always in the description below, as well as timestamps if you do get stuck on a certain spot. For this tutorial in particular, we're actually going to be working with a pre-made file and then building upon those concepts. So you can see there's a project file download, and this will download the Alphabetizer Swift project for you. Let's quickly talk about what we'll be accomplishing today. We're going to be walking through writing logic to handle correct guesses, showing the win or lose state, and make sure everything updates in real time, just like a real application. So in step 1, it actually asks us to explore the different project files, and it's kind of guided, but I'm going to take you along my tour of the project. So if we go ahead and open up our Alphabetizer Xcode project that we downloaded from the website, our files are currently broken down into folders. Always appreciate that. As much as I like to think I'm organized, I don't always break down things into folders. So let's go ahead and start off with our content view. This is going to be where we're kind of playing and handling the game logic. Now, as I mentioned briefly, this is going to be for an iPad game. So we can actually go to the bottom of our preview here, and we can click on the little menu, and we can change it to be the iPad 13-inch. If you'd also like to, at the very top of Xcode, we kind of have this drop-down menu to change our device when we boot it or we run it in the simulator instead of the preview. And I'm also going to select a 13-inch iPad. I'll do the iPad Air M2. If you haven't used, the iPad 13-inch before, when you load your preview, it might take a little bit of extra time. All right, and we can see that our content view looks exactly like the image on the right side. I'm going to make it a little bit bigger while we're going through this portion. So we have these different tiles. We can actually drag and move them around, and it seems like they want us to put them in the correct order, and then eventually we'll press the submit button. Currently in this scaffolded project, the logic isn't quite there, but our content view is essentially just calling upon some other views that we'll be taking a look at and is spacing them out a little bit more. So this is kind of where all the logic that we're wiring is going to end up in this project. We'll then take a look under the models folder. We have the vocabulary here, and this is our word source as well as our randomizer currently. It's storing a list of words, and we even have land animals and ocean animals kind of sorted out into two different things. And our select random words is our random logic. This is going to power our word bank. We'll then take a look at the other model, the tile model. This is the data model for each of those draggable tiles. It stores the word, position, and flipped state. It also has an icon and kind of like a placeholder emoji that we'll be fixing later. Let's take a look at the views, starting off with the tile view here. This is what is rendering our visual tile. If it's flipped, and we can even click on this, it'll show the check mark. Just as a note, in this tutorial specifically, we won't be talking about the animations. I do have a quick video on animations if you do want to check that out, but we're more focusing on the logic and design today. And this also handles our position, our drag with our offset and gesture. Although because we're not on the canvas, we can't move it on this view, but we could see that we can move it on the content view. We also have the submit button, which is really simple. We have our to-do statement that we actually need to apply the submit logic, but currently it's just a reusable button style. It will call the submit logic when we do tap it, and we're going to hook this up to the guess, valuation, and feedback. We also have the score view. So this is going to display the user's current score, and it is purely visual, pretty simple to understand this one. We also have the word canvas. So this might look pretty familiar to our content view without the kind of extra bells and whistles here. This handles the draggable tiles on the screen. It also builds that translucent placeholders for the layout. It positions and drags the tiles using the offset and gesture. And we actually use a smart centered offset here to make dragging feel a little bit more intuitive. And last but not least, we have our message view. This is going to show any win or loss messages, any feedback if they were close or try again, things like that, passed it as a string. And this is kind of just like a string message with a little bit of a background. We'll trigger this when the player submits a guess or wins or loses the game with the to do here, but this is essentially just a string message we're displaying to the user. So as you can see, most of the UI has already been built. We go to the content view, it looks like a game. We just need to really add the functionality. So the visuals, the structures, and even the animation is all here. Our job is to now really bring that logic in. So let's hop in back into the tutorial and discover how we can do that. All right, just scrolling down to section 2 in our tutorial here. So now that we've done our quick code review, let's go ahead and design an Alphabetizer data model. So in our models folder here, we're going to right click, or you can use the plus button in the bottom left, and we're going to create a new empty file, and we're going to call it Alphabetizer. Go ahead and create that. I'm just double checking my spelling. Spell check is such a crutch. Okay. At the top of this file here, let's go ahead and import foundation. And then we're also going to establish our class. We're going to call it Alphabetizer, just like the name of the file. And we'll add our brace. Think back really quickly to when we're creating structures or when we're creating classes. We're creating a class because the views that will share the Alphabetizer all need the same instance. So you can kind of think of this like the brain of our app. Okay, let's declare some properties in order to represent the states of the game. So we're going to create a private let, which is going to be for the amount of tiles. So let's go ahead and call this tile count. And we're going to set this to be 3. We're using let. We want it to be constant. There's always going to be 3 tiles on the screen. Then we'll create the variables to hold those different tiles. And this is going to equal a list of the tile. And outside of our square brackets, we're going to include the empty argument brackets. Okay, let's also create a variable for the score, and that's going to equal 0. So our tile count is the number of tiles. Our tiles holds the word tiles that the player drags around, and the score is the number of times that the player has alphabetized a set of tiles. We're also going to be creating a vocabulary. So we're going to create another private, but this time it's going to be a variable, and we'll call it vocab, which will be the vocabulary. So we're going to do our colon vocabulary. So we have a little bit of an error up top. It's saying Alphabetizer has no initializers. Now in the preview, if you have your window kind of shrunk like me, it doesn't always show all the code snippets. So let's go ahead and initialize our project. I'm always a huge fan of using the autofill. However, in this instance, we're only going to currently be referencing the ocean animals as the default. So we're going to reference our vocabulary to kind of provide it with that default. And we're going to have our vocabulary with a capital V equal the dot ocean animals. So if we go to our vocabulary set file real quick, we can see that we have 2. We have the land animals, and we also have the ocean animals. So we're grabbing the ocean animals as our default. Because we're using the initializer, we also need to include our brace, and we're going to set up that vocabulary. So self.vocab would equal the vocab. In step 4, it also wants us to create a function to hold the submitting. So still within our class here, but outside of the initializer, we're going to create a function to submit. We're going to leave the parameters empty, and we're also not going to include anything within this function. Instead, above the function, we're just going to add a quick comment with the double slash. We're going to say checks if tiles are in alphabetical order. So it kind of adds like a note as what this function will do. We haven't included the logic yet, but it's a good idea to add the comments. If you want to go to the next level, and this is really great if you're working on projects, or if you have one of those projects where you work on it and then like 3-4 months later you come back and you're like, what was I doing? You can actually do the triple /, and this will actually update your comment to be for documentation. That's right, you can create your own custom documentation. So if we now hold option and we hover and click on our function of submit, we can see checks if the tiles are in alphabetical order. So you can create your own documentation within your Xcode projects. Again, wonderful if you're working in a team or, a huge project solo. All right, in step 6, we're actually going to be adding another comment within our braces, and we're going to be calling this one a to do. Then we'll add our colon. Okay, what do we want to do? Well, we want to implement submit logic. And we can even kind of put a little placeholder here, right? Our score is going to plus equal 1. We'll definitely need to do a lot more work than that, but I'll show you why using comments and to-dos can actually be a really great navigational tool and organizational tool. So also within this file, but outside of this function, we're going to create another comment, and this time we'll call this one mark. We'll do private implementation. We're using this mark to kind of organize this individual Swift file. Really good if you have a lot of code, those Swift files where you get like 700 lines of code. You can use these marks to kind of separate different logic or processes. And in our initializer, it wants us to reference a start new game function. And then in step 9, let's actually create a new function here. And we'll make it a private function of start new game. And before we actually add the logic, let's add our documentation. So our triple / and we'll say updates tiles with a new set of unalphabetized words. And again, we can use our option click. We can see that it has reflected that change. So within this private function, we're going to create a constant of new words. And this is going to equal our vocab dot select random words. We're going to use the autofill here. We're going to implement the count, and the amount of words that we're going to have needs to equal the amount of tiles that we have. So instead of just putting the static number, let's reference our tile count from up here, which would be 3. We're also going to use a for, so we'll say for word in new words. Our brace, and we'll kind of loop through those different tiles in order to kind of populate them with those words. Have our tiles dot append. We're going to look at the tile, and then we're going to pass through the word, which would just be those different words. So it's going to kind of loop through all 3 of those tiles and populate them with those words. So in step 10, it wants us to learn a little bit more about navigation. So let's take a quick look at one of Xcode's underrated tools, the jump bar. So at the top of our Swift file here, we kind of have like our hierarchy, we're in our file. And then you can see here right now, I'm on the class of Alphabetizer. If we click on this icon, we can actually see all of our functions, all of our variables, and even special comments like our mark here with a little bit of a flag, and our to-do that kind of looks like a little reminder or checklist. And you can actually click on these different elements to jump to them as well as highlight them. So when you have larger Swift files here, let's say I want to go to the start new game, will actually be taken down within this file to where that is. And it also has this nice little highlight. So if you are looking for different things, you're like, oh man, where was I supposed to implement that logic? Oh, there's my to-do. You're able to, as your file grows, use this as a lifesaver for navigation. Think of it as kind of a mini outline that keeps you anchored. Think of it as a mini outline that keeps you anchored in big Swift files. So if you ever feel lost, just click here and jump straight to where you need. I also like doing my Command F when I have really big Swift files, but this is a tool that I should be using a lot more too. And as an extra tip, you can even structure your file intentionally with mark headers to make this bar even more useful. All right, section 3, share observable model classes. We're going to have to share this Alphabetizer class through the environment. We're going to be using our SwiftUI with that @observable data model class, independent of any single view. At the very top of our class here, and right before it, we're going to create an @observable. And if you've ever used @model in SwiftData before, this might feel a little bit familiar. Just like how @model lets SwiftData track persistent changes, @observable lets SwiftUI track logic changes. So anytime a property on an Alphabetizer changes, the UI will automatically refresh, no manual updates needed. This makes it perfect for driving the game's logic because SwiftUI can respond live when the player makes a move. And then step 2, we want to create an instance of Alphabetizer and store it within the environment. So we're going to go to our Alphabetizer app file here, and under the structure, but before the variable body of some scene, we're going to create an @state private var of our Alphabetizer, which is going to equal the Alphabetizer class we've created with the empty parameters. This also makes the object accessible in the environment. We'll see how that works next. Something we also need to do within our window group is just like with SwiftData, we kind of need to add it and call upon it, right? We're going to load into that content view, but we also need to include the environment. So we're going to do the dot environment. We're going to choose the one with object, and within the parameters, we're going to reference our Alphabetizer. It's the name of this variable. This way, when we launch our app into the content view, we have that environment context set up, just like with SwiftData. Heading on over to our world canvas here. And I'm just going to close the preview for a moment. And before our private variable of the tiles, we're going to create an @environment. And within the brackets, we're going to look at the Alphabetizer with the capital A. We're looking at that class .self. Outside the brackets, we're going to have the private variable. We're going to call it Alphabetizer so we can reference it. So I did turn off my canvas, but you will see that now that we've added the environment, that our preview will unfortunately crash. This is because the preview cannot find the Alphabetizer within the environment. You can see we have this crash here. So what we need to do, same with our app target, we need to scroll down to the preview here, and we're going to add the dot environment. And then within the object, we're going to reference the Alphabetizer. Oh, you might get some crashes for a while, might be pretty mad at us. But this time we're going to reference the class with the empty brackets here. So let's talk a little bit about why this is happening. Well, previews don't know about your environment by default. So just like how SwiftData needs a model container to preview data, we need to inject our Alphabetizer for the preview to work. Otherwise, SwiftUI is like Alphabetizer, never heard of it. So we do fix that by kind of wrapping our preview with the correct dot environment setup. The difference here is really subtle but important. In SwiftData, the key path infers the type. Here, we actually access the Alphabetizer by its type directly. We're also going to be replacing the local tiles we have here. You know how we have the first, second, third. They're more or less placeholders as well. And we're going to replace them with the tiles that are stored within our Alphabetizer. So we'll reference our Alphabetizer dot tiles. And move us back over to also having our developer tutorials open here. And we're also going to remove the @state because we're kind of handling everything with this class here. You will now notice that we do get a few errors. This is because the for each no longer has a binding to the tiles, which was provided by the @state. In the next few steps, we're going to transfer the responsibility for maintaining the model state from the word canvas to the model objects themselves. So in step 6, we're going to go ahead and open our tile Swift file here. And we're also going to make this @observable. You can see we have an error here because it is a structure. We're then going to update this to now also be a class. This will allow it to adopt that @observable flawlessly. We're going to return back to our word canvas view here. And we're going to scroll down a little bit to where we have our for each tiles. So for me, that's on line 20. And we also have an error hanging out here. And we're going to update this. Instead of being a binding, we're just going to reference the actual variable of tiles. We also have a reference to our binding. We have our tile in. Let's go ahead and also remove that, and we should be good to go. We can see our preview is thinking. That's awesome. We just have a quick error. Oh, that's because, we don't need to make this a list anymore. We should just use our braces. So we'll have our private variable tiles tile, and instead of the equals and then the square brackets for the list, we're going to be using our brace to grab the Alphabetizer tiles. Apologies about that. Okay, we should be able to boot up our canvas here, and we should be able to see a random display of words. Go ahead and zoom on in here. Ooh, there we go. We have octopus, crab, and jellyfish. Cool. So instead of the first, second, third, we have those 3 different ocean animals. It wants us to navigate to our tile view and remove the at state on the tile. So on line 4, let's just make it a variable. We're also going to resolve the to-do by moving on tap gesture the view into the preview. Okay, so if we ever want to find our to-do, we can use our little quick jump here. We have our to-do move into the preview. The tap to flip apparently is not going to be a feature for the final app, but it remains useful for testing the animation. So let's go ahead and highlight and cut with Command X. We're going to go to our preview, and let's go ahead and paste it down here. This is just going to be something that we can see in the preview, but not for the final game. We can also remove our to-do as we've accomplished that. In step 10, we're going to open up our vocabulary in order to declare a dictionary. So outside of our function random words, let's go ahead and create a static let. We'll call this one icons. And we're going to create a dictionary by using our square braces like we normally do. We're going to have our string. We're going to include a colon and also include a string. There does need to be a space between the two values. We're going to have this equal a list. We're using our square brackets, and we're going to declare the first item in our dictionary. So we need to give it the first property. We're going to add a colon, and then we're going to include the second property, which is going to be a bear emoji. I'm going to use the autofill feature there. For me, the emoji button on my keyboard kind of looks like a little globe. On my MacBook Air, it's paired with the function key. So we have a nice little explanation here. Dictionaries, like arrays, are collections that store other structures. Arrays store an order list of structures, while dictionaries associate keys with values. Here, the keys are the words and the values are the emojis. I like to think of scoreboards where we kind of have the key of that person's name and then the values might be their score. Right, it also wants us to add the remaining words to the dictionary. And we'll also add a comment. So we'll do each vocabulary word should have a corresponding emoji. And I'll just do this really quickly and probably speed it up in post. If you do want to work smarter, not harder, if you expand the page on step 11, go ahead and copy and paste those things in, but we should be good to go now. Okay, it wants us to now open up our tile. And where we have our fix me, we're going to make sure that we have the updated code in order to look up the emoji value within the dictionary using the word as the key. And if there is no emoji, we'll still use our fallback of our person shrugging. So here where we have our fix me in step 12, we're going to be updating that to just grab the value from the dictionary. And then for the otherwise, we'll show the shrugging emoji. So I'm going to remove our fix me comment here. And instead, we're going to reference our vocabulary dot icons, which was the name of the dictionary that we had. And then we're going to add our square bracket and look for the word. Then we'll use our double question mark as our nil coalescing in order to kind of say, hey, if you can't find anything, nothing's there, shrug. We don't know where that animal is. We don't have an emoji for that animal. As a note, if you do try to access an index outside of the array, you do get to crash. That's why we're using the nil coalescing operator, the double question marks. Unlike arrays, dictionaries save and retrieve values using a key in a constant time. Looking up a value in a dictionary occurs just as quickly whether a dictionary has 9,000, 100,000 different items or elements. All right, in step 13, wants us to update the preview in tile view. So let's head on over there. And where we have our tiles of word, let's go ahead and see the preview for the word bear. Wonderful, I'll make it a little bit bigger, but we can see our tile is now reflecting the correct emoji because we look up the word for bear and we say, hey, in the dictionary, this is the value that goes with that key. It's the bear emoji, right? So that's why using a dictionary can be so powerful. And then in step 14, we're actually going back to the word canvas and we should be able to see all the different animals with their name and their associated emoji within the dictionary. All right, great. We are moving on to section number 4. We're going to be connecting multiple SwiftUI views to one alphabetizer and display the different messages using enumeration, aka enums. I don't know why I said it like that, enums. Okay, step 1, we're going to be navigating to our score view. I'm just going to make our preview a little bit smaller here. We're going to be replacing our state private variable because we are handling score within our alphabetizer here. And we're going to be referencing that at environment with our alphabetizer dot self. We have a private variable of alphabetizer with the lowercase a. We also need to provide our preview with the environment as well. So after our score view and the preview, we'll do dot environment and that alphabetizer with the empty parameters in capital A. Now you also see in our score where we're kind of interpolating that score. Since that value doesn't exist anymore, let's go ahead and update that with the alphabetizer dot score, that variable. In step 2, we're going to be opening up the submit button, and I imagine we're going to be kind of recreating those steps as well. So under the struct of the submit button, let's go ahead and reference our environment. And if you really want to save time, you always feel free to kind of copy and paste. Otherwise, let's do our alphabetizer.self. And then we want the private var alphabetizer. And when we have our button where it says to do submit, why don't we go ahead and reference our alphabetizer with the, oh, I might get a little crash there. Let's go ahead and reference our alphabetizer variable. So that will be the one with the lowercase a. And we'll reference the dot. You might be getting a lot of crashes like I am. I'll reference the dot submit there. So if we again go back to our alphabetizer, we did have that function submit. We do need to implement it, but we're using that alphabetizer class or that brain to handle a lot of the logic here. So back in our submit button, make sure that we've established the environment. We're referencing the submit from our class, and let's update the preview here as well. And we'll have our dot environment of alphabetizer class with the empty parameters. Again, copy and paste from your score view if you would like to save some time. And see if we can actually refresh the preview really quick. I don't know if everybody else is getting those crashes, but sometimes it happens when we're making changes in the code and it's trying to refresh itself. Sometimes it freaks out a little bit. Okay, in step 3, we're going to be creating a Swift file within the models group. So I'm going to click on the folder, right click new empty file, and we're going to be calling this one message. The first thing we're going to do is import foundation. And then we're going to be creating an enumeration or enum with the enum keyword. We'll call it message and add our brace. So we're setting this up because Alphabetizer has no message string that we need to use within the message view. See here where we have the message, and this was an intentional decision according to the tutorials. In the next few steps, we're going to be setting up the message enum instead of using a default string. So we're going to create some cases here, and we can have a few of them. When I think of enums, I like to think of either the compass, where we have like north, east, south, west, or with game states, you know, playing game, paused, game over, things like that. In this case, we're going to have instructions. We're going to have another case of try again. And then finally, the case of you win. Now, remember that the message in our message view is a string value. So when we're looking at our messages, we can actually conform and force these to be a string. So after our message, we're going to do a colon string. Just as a note, by default, any of these cases are implicitly going to kind of have a raw string value of what those case names are. So if we literally just left it like this, instructions would just say it like that. Try again would have our camel case, etc. The good news is we can actually provide each case with an explicit raw value. So we can have it equal, and then we can have our string value. So in this case, we can say, you know, the instructions, place the tiles in the alphabetical order. Try again. It says like almost. I would just have this say try again. You can include emojis in strings if you want. So I'm going to do that. I think it's like the sweat emoji. I didn't want the one where he was like red and sweaty. That looked a little bit suspicious. And then for our win, we can say you win, and we can even include that trophy too. It's totally up to you. You can always feel free to customize your strings. Just make sure for the users it makes sense. So when using an enum with raw values, This is a data modeling decision. Enums are a very appropriate tool for a lot of scenarios with mutually exclusive options that share the same underlying type of value. So in this case, strings. Later in this tutorial, we're going to encounter the benefits of design over using alternatives like struct or static variables. Essentially with those enums, we're kind of locked into using those cases, which is also great for spelling mistakes, as Mr. Spelling Mistake himself. It allows us to make sure our code is very specific, and those cases really help us kind of stay organized. I always like it when I'm thinking about programming things and, oh, this is a good case for an enum. I used to actually not like enums, but they grew on me. Anywho, step 7, we're going to add a message property to the alphabetizer with the starting value of instructions. So let's hop on over to our alphabetizer, and under our score here, let's create another variable and we'll call it message. And this is going to conform to our enum message. And you can see here on the autofill, it is represented with the capital E. And then we can have this equal one of the cases. When we add our period, you'll see represented by the K's here, the instruction, try again, or UN. Let's default it to be the instructions. You know, we want people to kind of load in and be like, hey, this is what we're doing with the game. And again, enums are great because if I had like a dot game over and I was trying to like reference something, it doesn't exist. That value doesn't exist. I have to stick with what's defined already and predetermined within enum. Alrighty, in step 8 here, within our message views, let's go ahead and navigate over there, message view within our views. We don't have a whole lot of things here. Let's go ahead and also include our environment. And we shouldn't need this placeholder message anymore. We're going to be replacing this with our instructions. So at environment, alphabetizer.self, private var alphabetizer. I'm going to be a pro at spelling alphabetizer by the end of this one. We're also going to update the text that we're displaying to the user, and we can just reference our alphabetizer.message.raw value. And we can see here the string, the corresponding value to the raw type. Might just get a little bit of a preview crash because we need to also inject the environment within there. Oh my goodness. My preview is like, leave me alone, please. Okay, we're going to do our dot environment alphabetizer class with the empty parameters. Let's go ahead and refresh our preview. There we go. We can see place the tiles in the alphabetical order. So it's the default value of the alphabetizer.message as we've stated within our alphabetizer class, those dot instructions. Okay, on step 9, before moving on, we need to verify that the UN case also displays correctly. We can actually test all of our enums, and we're going to configure the data model within our preview to test for those different cases. So let's go ahead and augment our code a little bit. We're going to create a let and establish our alphabetizer, which is going to equal that alphabetizer class. Then let's go ahead and reference the dot message. You can kind of think of it as a very compact way of what we've already established before. And let's have this equal the .uwin case. Now we will get a quick error as we need to actually return the message view. I'm going to put return space before that view. You'll notice we still don't see the uwin message. That's still looking at the alphabetizer class within our code. It's kind of talking to the brain, which is default to the instructions. Instead, replace it with the alphabetizer variable we've created within the let statement. So in this case, it's that lowercase one. We can see that it's updated to uwin. If we change this to our other enum of try again, we can also verify that it works. All right, step 10, we are navigating on over to our content view, which is under the views right above message view here. You might also get a preview crash. Oh my God, the amount of crashes in here. Let's go ahead and insert our environment in the content view. So dot environment, you can be pros at this, alphabetizer class with the empty parameters. All right, let's go ahead and refresh our preview and our fatal error should go away. Here in step 10, this is a really good decision conversation. Why are we using the environment instead of passing alphabetizer down through each view? Well, technically we could declare at state variable alphabetizer equals the alphabetizer class in content view, and then pass it to every child. But that creates tight coupling. Every time, every single view would need to know about its parent, and that creates messy dependencies. By using the dot environment, we say, hey, Alphabetizer exists. Any view that wants it can grab it. No hardwiring required. This means score view and tile view can use the same data without even knowing that each other exists. It's cleaner, more modular, and you can kind of use this to share models across your entire view hierarchy. This is what makes SwiftUI views so reusable. They don't need to know where their data comes from. So hopefully that provides some context for step 10. I know there's a lot of text on the screen, but that's the way that I find kind of conveys what we're going through the best. Okay, section 5, and I think we only have a couple sections left. So it is now time to start implementing the game logic by filling out the submit function. It does also mention that we're welcome to use the preview in this section, but you won't actually have the operational game until the last step. I'm going to opt to reclaim my space by disabling the canvas here, and then at the end we'll pull it on back. Okay, let's go to our Alphabetizer, and we want to find the submit function here. Right now we have our to-do. Again, you can feel free to use the kind of jump to get to where we need to go. So the first thing we need to do is check if the tiles are alphabetized. And if they are, we'll add another comment to basically say, okay, if alphabetize, increment the score, right? Which we kind of have with our score plus equals 1 here. That'll just add 1 to the value. So something that does, as I mentioned, does happen when you kind of squish it. It's really great for the tutorials, but sometimes we do miss out information. So if we actually expand this and we go, oh, no spoilers, no spoilers. It kind of jumped us ahead a little bit. Oh my goodness. All right, we can see here that we are also updating the message to win or lose. Flip over correct tiles, delay 2 seconds. If alphabetize, generate new tiles. Flip the tiles back to the words. So I'm just going to get really lazy for a second and copy and paste these just so we're good to go. We'll be implementing all this logic as we go. Okay, in step 2, we want to create an isAlphabetized variable that alternates each time submit is called. So above our submit function, let's go ahead and create that private var. And we'll call it isAlphabetize. And we'll have this be set to false to begin with. And then under our check if the tiles are alphabetized, we're going to do our isAlphabetized dot toggle with the empty brackets. And let's just go ahead and add a to-do here. We'll put compare alphabetical order to position. Awesome. So we're going to first get the game working and then make it work correctly afterwards. In step 3, we want to only increment the scores only when the tiles are alphabetized. Otherwise, you can kind of circumvent how the game's played. I'm going to right click on score. Where's our embed? Oh, it doesn't want us to embed. Okay, we're going to have to do this the old-fashioned way. If is alphabetized, add a brace, and then we'll add our closing brace after the score here. In step 4, we're going to set the message corresponding to is alphabetized. So under here, update the message to win or lose. Message equals is alphabetized. We're going to use our ternary operator with our question mark. So if it is alphabetized, you win. Use our colon to say else. Try again. Again, use those enums. That's why we made them. We're then going to flip over the correct tiles so we can loop through these. So for tile in tiles, go ahead and add our brace. We want to check if this tile is the correct position. Remember that is alphabetized toggles between true and false, so we don't actually know which tiles are correct, and that's okay for now. Let's add our to-do statement. Check if this tile is correct. I guess it'd be is in correct spot. We can also add a little bit of logic first though. Let tile is alphabetized equals is alphabetized tile dot flipped going to equal the tile is alphabetized. Next, we're going to add the 2-second delay. So under our delay 2 seconds comment. So we'll start off by doing try await. Wait is a keyword that goes beyond asynchronous functions, which are functions that can be paused. So we're going to say, hey, try to do this. And then we're going to reference the task. From here, we'll do .sleep. Then within the brackets, we'll do 4. Then we can reference .seconds. And then within the brackets of the seconds, we can give a number. In this case, let's do 2 for 2 seconds. So in step 7, we need to wrap the task .sleep call and the remaining submit code. So before our delay of 2 seconds, let's add a task, add our brace, then all the way down here, before our other brace here, we're going to go ahead and close it off. So it's going to hold the delay, generating the new tile, flipping the tiles, and display the instructions. If you want to remember to the other developer tutorials, in the SwiftData one, we actually use task to preload the friend models into SwiftData while the view appeared, and outside of any SwiftUI views, task runs asynchronous code. Okay, in step 8, we're going to be adjusting task to also use the main actor. So after the brace of task, we'll do the @M main, then A actor, followed by in. So let's pause for a second to talk about something that's really important in Swift concurrency. Main actor. You may have seen it before. We used it in the sample data tutorial, but here's what it really means. In Swift, when you write concurrent code, especially with async or await here, you can run things in the background, which is great for performance, but there's a little bit of a catch. SwiftUI expects all UI updates to happen on the main thread, also known as main actor. Our Alphabetizer class is marked observable, which means anytime we update one of its properties, the view might react and re-render. That's a UI change. So if we update Alphabetizer from a background thread and SwiftUI tries to re-render, it's gonna boom and probably crash. That's where the main actor comes in. By annotating Alphabetizer with main actor, we're telling Swift, hey, all property changes on this class need to happen on the main thread. That keeps SwiftUI happy and our app stable. For a quick real-world analogy, you can think of main actor like SwiftUI's bouncer. If you try to change the guest list or your data from the background thread, the bouncer stops you unless you're on the front steps, that main thread. Okay, in step 9, we're going to be generating new files here. So if alphabetized, and a brace, we'll have our tiles.remove all, and then start new game function being called. Oh, sorry, if is alphabetized, there we go. In step 10, we're going to be flipping the tiles back to the word. So for tile and tiles, brace, and then tile.flipped, we'll set that state to be false. In step 11, we're going to clear the win or lose message and restore the default interactions. Okay, so in reality, we're just kind of updating the message back to be those dot instructions. It wants us to try out the submit implementation within the preview, watch the tiles get flipped, the instructions change, and everything goes back in 2 seconds. Okay, let's hop over to our content view. We're going to enable our canvas once more. Might take a second or two to load. So we're going to flip. The instructions are going to change, and then after 2 seconds, everything should revert. Okay, so we're going to press our submit button down here. Everything flips. Good job. You win. And then it goes back to the place the tiles in alphabetical order, but our cards are a little bit... they're a little bit all over the place. We could see here where they were stacked up on one another. So apparently we're going to fix that in the next section, which is section 6, enhancing our gameplay. So it's time to return to the UI and catch the gameplay up with some more game logic. We're going to make a variety of UI changes so Alphabetizer reacts and responds like a real game. Alrighty, step 1, we're heading back on over to the submit button. Just going to close my canvas real quick. We have to prevent the players from tapping the button multiple times by disabling it when the player actually sees the result. And because task runs asynchronously, submit needs to either handle concurrent tasks or prevent them from happening in the first place. Alphabetizer is going to be choosing the latter option there. So let's go to the end of our button here, and because of the way it's set up, we'll actually want to go to the brace after the label. So 2 up from the bottom here, and we're going to do a dot disabled. And then within the arguments, we're going to say, okay, what's causing it to be disabled? And we're going to reference a variable we have not created yet, and we're going to want the opposite of it. So we're going to look for the is enabled. It'll probably throw an error because it's like, hey, what are you doing? I don't know what this variable is. Outside of this brace here, so we're going to go down 1. We're going to create a variable called is enabled, which is a Boolean value. And this is going to be based on the Alphabetizer dot message. And we're going to do our double equal sign to look for the exact value of dot instructions. Another benefit of using the enum instead of a raw string, it's easier to check for those values rather than a string. What if I put a space? What if something is not capitalized the same, etc., etc.? The enum is going to control that. Enum relates to that game state, so everything is kind of talking back and forth to each other using the exact same parameters. In step 2, we're going to be adjusting the button when it's disabled. So if we go to our dot background here, we'll add a opacity based on is enabled. So if it is enabled with our ternary operator, 1.0. Otherwise, we can have 0.5. So when it's disabled, the opacity actually also drops by half. We can also add an animation. So above our disabled, we can add dot animation. And we can add the default, and the value of it will be based on whether or not it's enabled. In step 3, it's now time to fix the problem of a new game tile stacking on top of one another. That was pretty funny, to be honest. In Alphabetizer, we're going to be deleting, so we're going to go to our Alphabetizer file here. We're going to be deleting the tiles.remove all. We're going to keep the tiles, but reset their position whenever the player does win the game. So in start new game, you can scroll down here, or you can use your quick jump. Don't forget about that. We're going to wrap our existing code in an if-else statement. So the tiles should only be created once when there's no existing tiles. So I'm going to make a little bit of space here. If tiles.isEmpty, we'll add our brace. And then we're going to want to make sure that we're wrapping up this for loop. We'll add a closing brace there, so it's all wrapped up nicely. Now we are going to be adding an else statement. I don't think we're putting anything here right now, but it will essentially assign new words to existing tiles. We can leave our comment there. Oh, which is step 5. That's what we're doing down in step 5 in the else statement. There we go. So for the index in 0, we're going to use the ... less than tile count brace. We're essentially going to be looping over the tiles in new words and assigning new words to each of the tiles. Now there are 2 arrays, but for loops only operate 1 array at a time. Because the arrays are the exact same size, iterating over the range covers all the elements of both arrays. And apparently we're also going to be improving this step. And I know a trick from Python, which I know is also in Swift, which is what we'll be using for that. But let's not get ahead of ourselves. Let's go ahead and establish the tile, which equals the tiles. We're going to use our square brackets of index, and the word, which will equal the new words. We're going to look at the index there as well. Then we'll have our tile.word equal the word here. Okay, in step number 6, we're going to be using zip to assign new words to tiles. Like a zipper, it takes 2 groups by linking them piece by piece. So think of it as when we have 2 arrays and maybe we want to turn them into a dictionary, right? Maybe I have a list of people's names and a separate list of score. We can use zip to kind of merge them together. You might also want to think of it as like a double for loop. So let's go ahead and delete our let tile here, and let's update our for a little bit. So I'm just going to get rid of all the code there besides the for. We'll do the tile and the word within the brackets here. And we'll say in zip, and then we'll have our tiles and our new words. So it wants us to experiment and win a game, and when the tiles flip back, they should no longer stack on top of each other. Let's go to our content view. Turn our canvas back on. All right, I gotta do some serious gaming here. All right, crab. I think C becomes before those. Oh, and then W, it's pretty late. Let's go ahead and press play. We won. All right, now the tiles aren't stacking back on top of each other. Let's go ahead and do a little bit of fix in here. Try again. Okay, our game logic still isn't perfect. You'll notice that we kept the same sea creatures. I don't know why it told me to try again. We'll be fixing everything as we go. That's pretty funny. I'm like, this is the right order. Okay. Anyways, we got our experimenting of those cards not flipping back onto each other. Okay, in step 7, we're going back to the word canvas. Let's go ahead and hop on back over there. We want to use the dot on change to respond to the changes of the message. Dot on appear positions the initial tiles, but also needs to position them after every new game, right? When we were testing things out, it kind of just left on the tiles that we moved them to. So here we have our dot on appear, and after that, we're going to go down a brace, we're going to do the dot on change. And within the brackets, we're going to do of, then we're going to have our action, or something that's changing, which would be that alphabetizer dot message. We're going to add our brace here. And we're going to look for the old value and the new value. And we'll say in. And here we can use a switch statement to examine the old and new values of a message. So let's do the switch. Within the brackets, we'll have the old value and the new value. Add a brace. And right now we're just going to have our default, which would break. So above our default here, we now want to set the tile positions when the message changes from you win back to the instructions. This means that after the player wins and the tiles flip back to the new words, the tiles will animate to their initial positions. So we'll create a case, and we're going to look at the dot you win, and then the dot instructions. Say with animation, add a brace, set initial tile positions. If we scroll down, we can see it's an extension. It's going to distribute the tiles apart, but still centered. It's going to kind of take them and put them back in the starting position. It also wants us to experiment, so let's hop on back in our content view. We're going to verify that the tile positions reset after winning, but not when trying again. Okay, crab first, jellyfish, and the whale. We win. Okay, so it should reset the position. There we go. Let's go ahead and fail. Try again. And indeed, they do not switch back. That's awesome. All right, section 7. Check if tiles are sorted correctly. Evaluate the is alphabetized by comparing the tile position. Oh, I think we had a to-do here, did we not? There we go. So let's go ahead and hang out in our submit. So here we're going to check if the tiles are alphabetized. So let's go ahead and do let user sorted titles equals tiles dot sorted. Go ahead and add our brace, and we're going to be using the $0 dot position dot x. We're going to use the less than sign $1 dot position dot x. So what on earth does this mean? Why do we have dollar signs? Are we looking for a binding? What's going on here? So here we're using a closure to sort our tiles by their x position on the screen. Notice how we have the position.x and the position.x on both of them. This shorthand is super common in Swift. The $0 we have here represents the first tile, and the $1 means the second tile being compared. Swift will figure it out from the context. Just because you can use $0 doesn't always mean that you should. Ask yourself, would this be clear to someone else reading my code, or even to me 6-8 months down the road? You can use things like left side, right side. This essentially just refers to the first tile, then this the second. Think back when we're looking at arrays, the first element always starts with 0. So if you didn't want to write it like this, I'm going to go ahead and paste another example. This would be the exact same thing. We're looking at the first tile, the second tile, right? So I would use this example when the logic is more complex or unclear. The code that we just wrote. I use this when it's super short and really obvious comparisons. So shorthand is a great Swift trick but don't sacrifice clarity just to save a couple of keystrokes. Okay, after our kind of sorting logic here, let's go ahead and create another let. Well, this one will be alphabetically. Oh my goodness. I think I got it right. Sorted tiles, which is going to equal the tiles dot sorted. We're gonna add our brace. We'll use our $0 dot word dot lexicographically proceeds. Should be the first autofill for you instead of other sequence. We're gonna look at the $1 dot word. The lexicographical ordering is a dictionary ordering, what you expect when you think of alphabetical order essentially. This is the default ordering for strings that are Unicode based. Lexicographical, I think that's right. I should do the text to speech if I'm ever unsure, right? Okay, in step 3, tile needs to be equatable. So let's go to our tile.swift. This is essential because we need to be able to compare the two arrays. We're going to add the protocol conformance within an extension. Let's go all the way down here and extension, the tile class. We're going to make it equatable. And we're also going to add a brace. We're going to create a static function. We're going to use our double equal sign. We're going to do our left-hand side and our right-hand side. So LHS is going to be tile. And then the RHS also going to be the tile. We're then going to return a Boolean value. I'm going to leave this blank for now because in step 4, we're going to be assigning the IDs. So we're going to have the LHS ID equal the RHS dot ID. So for tile, the identity of the tile is important. A flip tile is still the exact same tile, right? I made a matching game. In my app word sage, I have like a little matching game. And yes, it's true. Whether that tile is flipped or not, it's still the same entity. Okay, in step 5, we're returning to our good friend Alphabetizer. We're going to move the is alphabetized into the submit function. So here we have our is alphabetized. Let's go ahead and cut it. We're actually going to paste it over our alphabetized toggle. Now we do also need to make some changes because right now it's a private variable. We don't want that. We want it to be a constant, so we're going to do let, and if it's always false, that wouldn't be good. So instead, we're going to have this equal our user sorted tiles, which is going to double equal our alphabetically sorted tiles. In step 6, we're going to be using our zip to iterate with the user sorted tiles and alphabetical ones and add a parameter representing, okay. So where we have our flip over the correct tiles, we're going to be updating this. For me on line 53, this 4 is now going to say tile. We're going to have the correct tile in, and we're going to go ahead and zip it up. So we're going to use the user sorted tiles and the alphabetically sorted tiles. In step 7, we're going to be addressing this to do here. And we're going to be updating the let tile is alphabetized to instead equal the tile, which would double equal the correct tile. So now the player sees which tiles are correct when they tap the submit button, whether that's one tile or all the tiles. Okay, step 8, recall that we've been using vocabulary.ocean animals with only 4 words. Oh yeah, that is true. We did it so long ago, I forgot. Let's go back to the vocabulary here. Yeah, we haven't seen any of the bears. We've only seen the crab, jellyfish, octopus, huh? So in our alphabetizer, let's go ahead and find where we're initializing it. Here's our init. Let's go ahead and update this for our land animals. Maybe in the future, if you want to have a hard mode or like a theme mode, maybe you can allow the user to determine which vocabulary they're using. Otherwise, congratulations. We have completed Alphabetizer. It wants us to play a few games and enjoy the results of our hard work. I'm going to go ahead and load this up on the simulator real quick. Went to the other monitor for some reason, so now I'm dragging it over, but great job. Let's go ahead and play a couple hands and then we'll check our understanding and then check out any ways if you want to go further. Okay, let's see. We got rabbit, duck, and lizard. Okay, so duck first, then lizard, because it's like ours all the way down here, right? Woohoo, we win. All right, it resets. We get a new set of animals. Okay, I'm going to intentionally make a mistake here, so we can kind of confirm that the logic works. And play, try again. Only the panda was in the correct spot. Move these around a little bit. Woohoo! We have indeed made a game that has great logic. Last one. Go ahead and hit submit. We did, and we can see our score incrementing, and our async is waiting 2 seconds before kind of fixing the game state there. Amazing. Okay, let's go ahead and check our understanding. So checking our understanding, which of the following is not a reason to use observable? So not. Update SwiftUI in response to changes in class properties. Share a model object through the environment. No, it actually does both of those things. So it should be the uniquely identify data models. That's right, we've used identifiable in the past for that. How do we connect two collections of data? Dictionary, that's not how we connect them, but that is a collection of data, but it's not how we actually merge them. Task, that's something where we're using async. Zip is going to be the answer there. It's going to take those two things and like a zipper, kind of merge them together. All right, last question. Which of the following is an advantage of splitting code into multiple files? Smaller files are easier to understand or it runs faster. It is just the fact that it is easier to understand. I've been there when I first started Swift coding. I didn't know what MVVM was, and my goodness, some of my code files were like 700 lines long in a content view because it was handling so many different things. Yes, splitting them up is an advantage, easier to understand, even when you get really into it with like folders and naming things appropriately. So good to split it up. Great job. We can read the article really quickly, but essentially we talked about working in an existing code base, changing the target device to an iPad. We learned about to-dos, fix-me's, as well as those quick jumps, learning about observable, which is a really huge and great concept. I think a lot of people struggle with having views talk to each other outside of the state management. So great job there. We learned about task sleep to kind of give people a pause, and zip. I love using zip. I've mainly used it in Python, but it's cool to use in Swift too, to iterate over those pairs of data. If you do want to extend your app, you can track the number of times the player attempts and maybe, kind of display a win rate there. And you can switch to a new set of vocabulary after each game, maybe also kind of do the different difficulties as I mentioned. It's totally up to you. So great job. As a sneak peek for the next tutorials on Develop in Swift, they've added these quite recently. We scroll down. Machine learning is what we're going to be covering next. I might kind of brand it as its own machine learning tutorials, so be on the lookout for those if that's something you're looking for. There is also spatial computing, so developing for Vision OS. If you're interested, the developer.apple.com is an amazing resource for learning SwiftUI. So if you enjoyed this video, go ahead and drop me a like, subscribe if you're enjoying the content, because there is so much more to come. Dream big, code bigger, and we'll see you in the next one.